Good morning. I'm going to present you a part of my PhD work, which focuses on the quality of agroforestry wood. Agroforestry can be defined as a set of land use practices which aim to realize the benefits from growing woody and herbaceous species together, commonly by the addition of trees to land already being used for pasture or for growing annual crops. It's a very old practice that disappeared in the middle of the 20th century with the emergence of intensive agriculture, but in the 70s, this intensive agriculture showed weaknesses and agroforestry gradually reappeared. We have to know that agroforestry trees grow in very different conditions than forestry tree system, mainly because of their higher exposure to wind and light, to strong interactions with annual crops, and to numerous human operations on branches and root systems. Until now, agroforestry woods have not been studied a lot for their quality, so our research aims to understand how those particular growing conditions affect the development of trees, especially primary and secondary growth and wood quality. In a first stage, we have focused on hybrid walnut located into the Restanclière agroforestry platform in south of France. Our studies focus on two walnut tree plots. One is an agroforestry and the other is a forest plot. And the density in the agroforestry plot is lower than in the forest plots. In the agroforestry plot, between each line, several crops are cultivated every year, and in the forest plot, walnut trees are mixed with other tree species. A growth monitoring is made since 2002 with an annual DBH measurement. It allows to determine the primary growth and the radial growth of the agroforestry walnut trees compared to those from the forest system, and we have those to the density and remuneration on radial increment curves in the two plots. The annual monitoring of walnut tree growth showed two things. The first one is that radial growth in the agroforestry plot is on average 50% greater than those in the forest plot, and the second one is that the height of walnut tree in agroforestry plot is also more important than those of trees from the forest plot. So concerning the radial growth, our results are in agreement with observation made on the impact of stand density on growth, and a study made in 2004 also showed that in agroforestry system, the spacing of the trees favored radial growth. Concerning axial growth, our results are not conform to the observation made in other studies, which indicates that agroforestry trees are usually smaller than the forest trees. However, our plots used in our study are surrounded by large edges that can reduce the effect of the wind on the growth of the trees. So this could explain why the agroforestry walnut trees are not smaller than the walnut trees from the control forest plots. So concerning specific density, our first results show that there is no differences between the infradensity of agroforestry wood trunk and those of forestry. So to conclude, we have shown that agroforestry walnut produce more biomass than walnut from conventional plots at the same age. This result is potentially interesting for the wood industrial sector, but also for the farmers, because their walnut trees can be a significant source of additional income at the farm level. And lastly, this study of growth and thigmomorphogenesis in an agroforestry environment is not finished. We also study the impact of wind on the radial and apical growth on agroforestry trees in an agroforestry system of black locust in south of France.